Okay, so it's now recording. No, don't be silly. So, the purpose with the elimination methods is that you get either you keep the equations as they are, and then you get the number of x's or the number of y's the same, and you don't have to worry at this stage about whether it's positive or negative. Okay, so you have to do something to the equations to get the same number of x's or the same number of y's. There are a couple of suggestions. Who can make a suggestion as to what options we could have to make the same number of x's or the same number of y's? Angus?
You could find the thing they both go into.
Yep, so what are you going to do?
You could times the 4 and the 2 together to make 8.
Yep.
They both go
Can't you
into 8.
get
Yep.
both 4?
And if they both went into 8, and therefore you times the top one by
8. No, 2, sorry.
2 and the bottom one by
8. No, 4.
4, and you get 8. Yeah. Okay, so you could do the top one by 2 and the bottom one by 4. That would give them both have 8x. Yep, absolutely brilliant. Anyone got any other suggestions? Because that's not the only way. Yes?
Times both of them.
No. What would you do? Because
Times 2.
yeah, times the bottom one by 2. I think that's the easiest way. There is one other way that you could do it. Yeah.
Could you divide the top one?
Yeah, you could, but what's the problem with... You could do that, but what's the problem with doing that? Yeah, you end up with decimals, which is just horrible. So we try and avoid decimals, but you could do it.
Yeah.
Yep, absolutely. The other way you could do it, you could multiply this one by 5 and this one by 3, and that would do it as well. Okay, but we're going to do Cecily's way because I think it's the easiest, yeah? And I'm just going to write down here, I'm going to do equation 2, and I'm going to multiply it by 2. So I'm just reminding myself what I'm doing, and I'm going to write down that is 4x minus, help me out, 10y equals 26. Okay, so I've now got these two equations, and I'm just going to write them down. I'm going to call this one equation 3, and I'm going to rewrite equation. Okay, so now I've got equation 3. Okay, and I've still got my equation 1 there. So I've got two equations that now both have 4x in. Are we happy? Okay, apologies. Yeah. But can you see we've got x is the same. Now this is where elimination gets you quicker to that equation with just y's in. We need to do something to both equations that will get rid of the x's. So what can we do between equation 3 and equation 1 that will get rid of the x's? Cameron, I think, was marginally first. What do you think?
Just minus 4x from both.
Yes, but that puts it to the other side. We can actually do something to both equations, combining them together in some way, that gets rid of not brackets.
Make it how you make it in this.
No, you won't have seen this before unless you've seen it. So I'll have a go. So what you do is you can subtract. Take equation 3, and you subtract equation 1.
Wait, what?
Okay, so this is the revolutionary bit. So 4x minus 4x will give you 0x. Minus 10y minus 3y minus 13y. You happy with that?
Yeah. No, wait.
Yeah.
Oh, yeah.
Do we have to use this way?
No?
And then you got.
If you get the other way,
I know the other way, and this way's confusing.
okay, that's fine. But I am showing you because if I don't show you, then some people will go, oh, there's this other way. It's called elimination. It's way easier. And Mr. Goodman never showed it to us. And why didn't he show it? Yeah? Okay. Minus 13y. And then you've got equation 3 minus equation 1. So 26 minus 39.
Yeah,
Minus 13.
No, so wouldn't it? What, you don't get 26 because that's equation 2.
No. This is equation 3 because this is the one that's been multiplied.
What would happen if you got given? Shut up, okay? I don't get this.
Yeah?
I get
Yeah. Can I just go to the end?
I mean, if this gets posted on YouTube.
So
Minus 3 or no? Could you do equation 1 minus?
yeah, you could, and then they'd end up with all positives. Okay, Sessions were spotted that actually it would have been much nicer, and I've deliberately not done it the nice way to begin with. But you can see if I'd done 1 minus 3, I'd have ended up with much nicer numbers. But it still works. 3 minus 1 is 26 minus 39, which is minus 13.
So y equals 1.
Which means minus y equals minus 1, which is y.
And so what have I got to divide by to solve this?
Minus 13.
If I divide by minus 13,
Then you could skip a step.
I can do it in one go. Y equals 1.
I am very confused.
Okay. If I then I then need to find out what x is, and this is where this method is slightly slower at finding what x is. I now have to use equation 1 to find out what x is. So equation 1 says 4 times y plus 4 times x 4 times x plus 3y, and y is 1, equals 39. Okay, so I've now got 4x,
Why do you do 3 times 1?
because y is 1, and I'm just using the top equation, equals 36. So then divide by
7.
4.
Well, it's 7. X is 4.
X is
Yeah.
12.
No.
No, it's not.
4's into 36, go
12. No, what? How have I got 12?
9.
Sorry, that's
9. Thank you, Debbie. Yeah, 9. And now I can check that this works in the other equation.
It does.
In equation 2, 2 times x, 2 times 9, minus 5 times 1. 18 minus 5 is 13. Tick, check, and I know that I'm right. Okay? So this is the same equation, but I'm going to do it the harder way so that you can see how it still works if I do it the harder way using elimination still. So
slow it down a bit.
I've got equation 1 and equation 2. Yep. I'm now going to multiply equation 1. I'm trying to get the y's to match up. So I'm going to multiply equation 1 by...
2.
No, I'm going to get the y's to match up. No.
5.
5. Yeah.
Oh.
Yeah, and then I get
2 by
20x plus 15y equals, and this is a bit big, but 390 multiplied by 5 I think is 100 and 190.
Wait, 100.
190.
How is it 190?
No, 195.
No, it is 190 because. No, it's not
195. It's 195.
195, sorry.
Yeah. Check your time.
195. Okay. And then number 2, I'm going to multiply it by 3. Okay, so we're on that now, and we can see that we're going to get 6x minus 15y equals, multiplied by 3, I can do that one, 39. Okay, so I'm going to now label this equation 3 and this equation 4. Now, here is the difference between this method and the other method, and this is the key thing that you need to pick up. Okay, I've got 20x plus 15y equals 195. 6x minus 15y equals 39.
That's wrong.
It's fine as long as I now do a key step. Okay, what do you think I have to do to combine those two equations to get rid of the y's? Yep, and how am I going to cancel them out? Cecily? Yeah, yes.
Add them together.
Add them together. If I add equation 3, you remember last time we subtracted them, and this does what we were saying here. If we add equation 3 and equation 4, 20x plus 6x is
26.
26x. look at this. Plus 15y
Minus.
plus minus 15y gives you
Still that.
no y's. Plus 15y, and then you add on minus 15y, you get no y's.
Exactly.
Yeah.
This is different to the original method you taught us as well. Isn't it? I think I just prefer the original.
Yeah, that's fine.
Yeah, but
That's fine.
Keep it OG.
And then let's keep going. 3 plus 4 is, add this together, 4 and 1. 10. Sorry, that's 14. 9 and 3 and 1 is 13. So 2, 3, 4. If I then get x, I've got to do a bit of division here. 26 is into 2, 3, 4. I get my calculator out and I do that.
260 is 10.
Many.
Yeah. So it's going to be 9.
I think that's an easy.
Yeah.
I think that's
Cool.
the way I.
Yeah. You might have seen this before. I've then got to get what y equals, so then it's back to the same method that they all use. So I've got to substitute this into equation 1, and I get 4 times 9 plus 3y equals 39. 4 times 9 is 36, so I've got 36 plus 3y equals 39. So 3y, take 36 away, 3y is 3, so y is 1. And if y is 1, then I can now check that that works in equation 2.
Sir, for the bit where you plus 3 and 4, and you put and it says 26x equals 23, and then
234, 234.
Oh, 234.
Yeah, sorry.
Oh,
Yeah.
okay.
So check in question 2, sorry. And so I've got 2 times 9 minus 5 times 1. 2 times 9 is 18, minus 5 is 13. Check. I know that I'm right.
Yay.
Okay.
I like this method.
We are going to solve simultaneous equations by substitution,
Yay.
Cecily.
Yeah.
And we're going to solve the same equation that we solved last time, but we're going to solve it by a different method, so that you can start to see, because this is quite a good example of something that is relatively difficult to solve, and you can kind of then see how we go about solving it. So this is called substitution. The key to substitution is that idea of if something goes off, you put something else on. So that idea in sport where somebody is substituted, you take somebody off and you put something on in its replace that is going to make the situation better, hopefully. Okay. And so what we need to do is we need to rearrange one of them, one equation, to get either x equals or y equals. Okay, so that's our aim, Hugo, is we're going to aim to get one equation to do x equals or y equals. We could do any of those. There are kind of 4 different ways that we could do that. Okay, there's probably one that's probably a bit easier than the others. If you are feeling confident about this method, can I suggest that you do a different one from me? So if you're feeling confident, do a different substitution from me. If you're not, then do the same substitution as me. Which do you think is the easiest one to rearrange to get x equals or y equals? Cameron, what do you think?
The bottom one, because all you have to do is plus 5 to both sides.
Plus 5,
2,
5,
5y.
5y, and
Then minus 13.
no.
Top one you could just do 4
No.
minus 4x.
So I could minus 4x, and then to get y on its own, what would I need to do?
Oh, it's just y.
Yeah.
Divide by 3.
I'd need to divide by 3. So the top one I could minus 4x and divide by 3. The bottom one I could add 5y and then
Minus 13.
if I get 2x on its own, how could I get the x on its own?
Just divide by 2.
Divide by 2, yeah. Okay, so we're doing a different method. Yeah, if we were going to get the x's the same, we would times the bottom one by 2, and then we could do it by elimination. But we're going to do a different method. Okay, so you need to accept that this is a different way of doing it. Yeah. Okay.
The harder way.
There, with all equations, okay, there is generally one method that is slightly easier. Okay. Substitution, you have to use substitution in some later questions in algebra. Now they kind of go into quadratics and we haven't quite got there, but understanding the principles of substitution is really important, but it often ends up not being the easiest method. Okay?
So it's easier in the short time and long time. It just makes it harder.
Yeah, it's easy for some. So hopefully you'll see which questions are really easy. We'll have a look at some questions as to which ones are easy by substitution.
I'm a tiny bit confused on what we're doing right now. Are we still doing? So we still have 4x and 3y, and equals 39, and 2x minus 5y is 13.
Yep.
And
We're trying to solve that.
huh?
We're trying to solve
We're
that.
not doing. Have we done the first bit already?
No, we haven't done anything yet.
Okay.
Okay, so I'm going to rearrange the bottom equation to get x equals. So the first thing that I'm going to do is I'm going to get 2x, and I'm going to add, what have I got to do to get 2x on its own? I've got to add plus 5y. Can I encourage you, it was really difficult to follow some of your working because this bit wasn't separate enough from your working. It was the same size, it was really close to it, it wasn't obvious what you'd done. So we're going to add 5y to both sides, which means we get 2x plus 5y.
The equations aren't the same. The x's aren't. The x's aren't.
The x's aren't the same. No, we're doing a different method. The x's don't have to be the same.
Okay.
Why is the x so far from the equal sign?
Because I keep my x's lined up, my equal signs lined up, my 13 lined up, and then my 5y goes on the end there. Yeah, good question. Then to get x on its own, what do I now need to do? If I've got 2x equals,
You need to get to equal that y, so you need to minus the y, 5y.
no, I'm trying to get x on its own.
Divide by 2.
Divide by 2. So I'm going to write over here, divide by 2. And I'm going to divide by 2 over here. If I divide by 2, this side becomes... No, this side becomes... so you can't see where I am. This side becomes x. And the other side, I'm just going to write it. You could do it 7.5 plus 2.5, 6.5. I'm going to just write it divided by 2. I'm just going to divide the whole thing by 2. Okay?
But can we do 7.5 and 2.5?
Yes. Yeah, but we don't tend to put decimals into algebra. We tend to kind of do fractions. So 6.5.
Wait,
Because we've got 2x and I want to get x. This substitution relies on, the key bit of substitution is we get x equals or y equals in our first step. That's the first step that you do.
Plus 5y, you get 3y. You still got 3y. From the other question.
I'm doing it to the bottom equation. I'm plussing 5y. So I just get 2x and I plus 5y onto that side, so I get 13 plus 5y.
Yeah.
Yeah. So I've just used one equation
Yeah.
and I've rearranged that one equation to get x equals.
Can't we do the one you said about elimination?
Okay, please. There is a reason why I'm showing you all three methods. This method, you must use it in some more complex questions that we will come on to. Non-linear, thank you. Good vocabulary. And we will solve those ones kind of later down the line. But if you've seen this method now, and some of you really might like this method and might go, this is the one for me. I'm going to just use this one. Interestingly, this is the method that I didn't really know about any other methods when I was at school. I used this to solve everything. This was the only method that I had. Okay.
Did you not get shown, or was it just...
I don't know, or it didn't make sense to me, and therefore this one made sense, and therefore I just used this one. Okay. So we've got x equals. Is everyone happy that is a rearrangement of that equation? You might not yet know why we've done it, but you get that it is. Yep. Okay, so why do we do that? We now substitute x into the other equation. Okay, so which is the other equation that I'm talking about?
4.
Yeah, this one here, the 4x plus 3y equals 39.
Should we put that in brackets?
What, the bit in the words?
Yeah,
You can put the...
No, the 13 plus 5.
Yeah, absolutely. So then what I'm going to do is where I see x, what am I going to write down, Tallulah? Where I see x in this top equation, if I am substituting for x, what am I... Write this equation. Spot on. Yeah? So I'm going to do 4... and then I'm going to put it all in brackets because it's a big long thing. 13 plus 5. Is this what you meant, Tallulah? Yeah. Over 2. What am I now going to write? Tallulah, just finish it off. Plus 3y equals 39. Yeah, I am. Okay, so we're going to take it out of the brackets in a moment. Before we take it out of the brackets, I'm going to get rid of this horrible fraction. Okay, a number of ways we could get rid of this fraction. I could see that it cancels there with the 4. That's one way of doing it. I'm going to do a way that will work whatever we have on the bottom here. I'm going to multiply everything by 2. Okay,
What, even 2 by 2?
I'm going to multiply the whole of this first expression by 2 to get rid of the fraction. So I'm going to multiply by 2 to get rid of the fraction. Now here, if I multiply something that I've divided by 2, what do I get?
0.
No.
Divided by 2.
The original. If I have something and I divide it by 2 and then I times by 2, I get back to where I started. So I've got here 4 brackets 13 plus 5y.
Well, why couldn't you just go straight into 13 plus 5y?
Oh no.
Why couldn't you just put that straight back into the bracket? Oh, so can you explain that again?
Okay, so I've times this by 2. I've times this thing by 2. Why? Because I don't like the fraction that's here. It's going to make it harder for me to solve.
You could have just gone from 13 plus 5y straight into the bracket. Why did you have to...
Have the divide by 2 because I needed, because I'm substituting in for x, not for 2x. So I needed x is this divided by 2. Yeah.
If you're timesing it by 2, surely you'd have to times the 13 and the 5y.
Yeah, so it'd be
Okay. If when you times a fraction, if you times the top and the bottom by 2, have you multiplied the fraction by 2? No. If I times the top and the bottom of a fraction by 2, so if I've got 5 over 10, and I times the top and the bottom by 2, I get 10 over 20. Is that multiplied by 2? It's the same thing. So if I times this and this by 2,
It's just the denominator.
so I just get rid of the denominator because that's timesing by 2. So 5 divided by 10 times by 10 is 5. Yeah? So if I want to times this by 2, I can just get rid of the bottom. Yes, Darcy? It's not very helpful given you need to understand this. Yeah? Okay, you better go. Yes? Absolutely. So I've got to times this by 2.
Which is 6
6y, and I've got to multiply this by 2, which is 78. Okay. Now somebody said multiply out the brackets. Yep. So I've multiplied everything by 2. I'm now going to multiply out the brackets. So this becomes 4 times 13, which is 52.
Wait, why did you times that by 4, not by 2?
Wait, surely we can just do plus 26y. Plus 26y. Plus 26.
Plus 20y. Oh, yeah, plus,
26.
I'll do it in 2 stages.
Wait, what?
Plus y.
Double the inside of the brackets when you said you double the inside of the brackets.
This is such a long way.
Yeah, I would.
Yeah, I will put it on. Yeah. I've put it. I'm going to put it at the same time as the other one.
Do it like we have.
So 52 plus 20y plus 6y. Well, now how many y's have I got? I got 52 plus 26y
So y
equals 78.
Then take away 52 from both sides.
Yeah.
Okay, and then then this should start looking familiar to you. Okay, I'm now going to take 52 from both sides.
How did you get 52 plus 29 plus 6y?
I have to multiply out the bracket. 4 times 13 is 52. 4 times 5y is 20. Minus 52 from both sides leaves me with 26y equals 26.
So why
y equals 1, x equals
So I'm dividing by 26,
So that plan.
It's 1, isn't it?
and y is 1. Y is 1, and then how do I then find out what x is?
Do the equation.
Yeah.
question, please.
So like
X equals 9.
plus 3
X equals
equals
9.
39. So
X equals
39
9.
minus 3 is 4.
X is like
4x.
3 equals 39. 4x equals 36. So x equals
9.
9. And then once you've got x equals 9, what have you got to do? And this is the bit, Louis, that you didn't do that would have told you that you were doing something wrong at the beginning. You've got to do the check. And what do we do to do the check?
You fill it in. Put x as 9 and y as
Yeah.
1.
So 2 times 9 minus 5 times 1. 18 minus 5.
13 says correct.
13.
Oh no, I didn't do that.
Therefore it's correct. Yeah, you didn't do that.
Question.
Okay.
Would this method only usually be used